Right? So we have seen that the first one will be 9, 1, 0.25, 0.04, 18.49. Then you have to find the sum. So what will be the sum of that? The sum? Add the two, add the numbers, gives you what? 29? When you add this one, 9 plus 1 plus 0.25 plus 0.04 plus 18.49. What are you getting?
27.
Huh? 20 what?
27.78.
27.78. 28 point what? 78. Right, yeah, 28.78. It's 28.78. 28.78. We are deciding. Huh? So it is 28.7. Now when you add here, you divide by what? How many numbers there are? Find variance, right? Find variance divided by how many numbers there are. So remember the formula for variance is this one. You are dividing by n. You divide by n. So variance is equal to 28.78 divided by variance is equal to 28.78 divided by how many numbers are there? 5. Good. Do that. 5.7. 5 what? 6. Assuming you are saying correctly, but I don't know. Assuming it's like that. 5 point that. Your variance. Then let's find this standard deviation. Is your square. You are removing this one. You are square rooting this one. 5.756. That's what I say. Yes. What would be that? 2 point. What? Standard deviation. 2.4. That are we confused? Are we confused? Are we confused? Huh? What's the answer?
2.39.
Yeah, 2.39. Is 1 dB 2.4. Good. I'll just come 2.2. That? Is that? Are we together? Then you will notice that for the first one we go to 0, standard deviation, what's 0. This one is variance 5.7 that one and this one. If you try on your own to do this one, when you go home, you will discover that the standard deviation for this one, the last one, is going to be 123.3. For this one, for the third one, you 123.3. As this is standard what? Deviation. So standard deviation for the first one is 0. Standard deviation for the second one is this one. Standard deviation for the third one is this one. So what is it telling us? It is telling us that because the standard deviation is high, it's going to be the number is going to be very huge. There is a wide spread of data, because standard deviation will measure how spread that data is. So here, it's the more the figure, when the figure is small, the more the figure, this one, okay, it means there is spreading, there is spread of data. There is spreading of data simply because the numbers are becoming, standard deviation is becoming huge here, comparing to here. 0, there is no spread of data. Here, spread of data is there but not much. Here, spread of data is there but very much. That's what I'm saying. For you to know the spread of data, especially at Management, for them to standardize, they use standard deviation. How far is it with the other students? You find plenty of them they have failed. Just very few they have passed. They use standard deviation to standardize, so that they are bringing them together and then they know what they can do. We call standardization. Right. Why are we bothering to know about this standard deviation? It's easy for you. It can tell standard deviation can lead you to know if it is production of commodities. For you to know which machine is very powerful, you use standard deviation. To know which machine is very powerful, you use standard deviation. Let me give you an example. I'll be writing for the sake of our friend. I'll be writing. I'll not dictate now. I will not dictate because I know I have my sister here, so I can't dictate again. Let me. Two machines. Example. In other words, we are saying two machines, A and B, are used to pack biscuits. Are used to pack biscuits. A random sample of 10 packets was taken from each one. A random sample for 10 packets were taken. And the results were recorded as below. Machine A, machine B. Work out variance and standard deviation for both machines. Which machine is reliable? Right, let's start with the machine A. Let's start with machine A. X minus X bar X minus X bar square. Would you do both machines, machine A and machine B, and you find the standard deviation. Machine A 96, 198, 198, 199, 200, 200, 201, 290, 190, 202, 205. I will only do for the first one. The second one you can do it when you are at home, right? For machine B. For machine A, first of all, find the mean. Find the mean. Add the numbers. Add the numbers, all the x's divided by n. You add all those numbers divided by n. Find what is that? Add all the numbers here divided by n. What's the mean? Huh? What? 200. Let's do it together. Another one. You go to what? Yeah, 10 of this. 200. Yvonne! Add them, divide by how many they are? 200. Right? For the first one is 200. 190 what? X 196 minus 200. 198 minus 200. 198 minus 200. 199 minus 200. 200 minus 200. 200 minus 200. 200 minus 201 minus 200. 201 minus 200. 202 minus 200. 205 minus 200. The first one here is going to be negative 6, negative 4. Negative 4. This one, negative 2. This one, negative. Negative 2. This one, negative 1, 0, 0, 1, 1, 2, 5. Right? If you try to add this, you are going to get a 0. If you try to add yours, you are going to get a 0. That's why we come up with this column here. We are deviating. Zero. That's why you square this. It's going to be 16. 4 squared is 16. And here 4. Here 4. Here 1. Here 0. Here 0. Here 1. 1. Here 4. Here 20 what? 25. Right? Add these numbers here. Add these numbers. Sum these numbers. Add the numbers. 56. Divide by 10, which gives you 5.6. And this is your variance. So variance is equal to 5.6. Standard deviation square root 5.6 gives you 2 point something. 2.2. This is for machine A. Go to machine B. Machine B. X minus x bar. X minus x bar squared for machine B. One 192, 194, 195, 198, 200, 201, 203, 204, 205, 207. Again, if you find mean for this mean, it's just the same 200. Again, when you add all these numbers, value how many they are, you get again the same like this one. Therefore, mean again is going to be 200. So the first one is going to be 192 minus 200, 194 minus 200, 195 minus 200. 198 minus 200. 200 minus 200. 201 minus 200. 203 minus 200. 204 minus 200. 205 minus 200. 207 minus 200. For this one, it's going to be minus 8. Here it's going to be minus negative 4, negative 6, negative 5, negative 2, 0, 1, 3, 4, 5, 7. Now, add the numbers here. You square them. 16, no, 8, 8, 64, 36, 25, 4, 0, 1, 9, 16, 25, 7, 7, 49. Add these numbers. When you add these numbers, you have already them. You have divided by. You added this 64 plus this plus this plus this plus this plus this. You added them. You have added them. 2 what? 229. Divided by 10. Divided by 10. 22.5. When you add, you are getting. When you add them, you got what? 229. 229 divided by 10 gives you 22 point what? 0.9. This is your variance, right? This is your variance. Variance. How do you get standard deviation? When you add them, are they giving you 229? Are you sure? Serene? When you add them, is it giving you 229?
No, the trick today.
Huh? Where are you?
I'm still on the second column. X minus X prime.
When you 64, 36, 25, 4. 4. 0, 1, 9, 16. 16. 16. No, it's not 25. 16. I cannot use 6. Because if you want the first data, not 206. Okay, 206, not 205. What is 206?
Yeah,
No, yeah, 206. So if this 206 is going to be what? 6, eh? What is it? 30 what? 36. Maybe that again, yeah. So I think it will be 36. 36 and 49. The part is in the units. 16, 36 and 49. 16, 36 and 49. So there. True voice. True 40 divided by 10. 240 divided by what? 10, which is what? 24. This is your variance, right? And standard deviation, square root, yeah, variance 24, right? Which gives you 4.9. Yeah. 4 point what? 4.9. Now, let's see which machine is very powerful. In other words, which machine is reliable that you can depend on. If you are given two machines, if you look at this one, reliability of machines will depend on various. Not the smaller the various, the reliable it is. Now, if you look at this one, which one has got small, which one has small variance or standard deviation? If you see that that machine has got, it's giving you little standard deviation, then it is very reliable. Which machine is reliable? Machine A. Therefore, machine A is more reliable than machine B. The reason being that machine A is more reliable because it has the variance is smaller than machine B. The fact that the variance is smaller, is actually smaller than the other, it becomes reliable. Machine A has less variation, indicating that it is more reliable than machine B. Machine A has less variation, indicating that it is more reliable than machine B. Machine A has less variation than machine B. In other words, the machine that has less variation Machine A has less variation, indicating that it is more reliable. And just to write it properly for the sake of our friend. Machine A has less variation than machine B, indicating that it is more reliable. Indicating that it is more reliable than machine B. Right? So let's bring it up, right? How we guys go? What's he saying?
No, we're having another class.
I thought we have the bread. Is it clear what we have done? Ready?
Yes.
Have you?